For some people, eigenvalues and the eigenvectors are no longer two terms, especially if you are in the field of mathematics and in physics. Because in physics, we've got eigenvalues and eigenvectors, though the computations, both in physics and mathematics, differ. But here, it seems a bit difficult to compute three-dimensional eigenvalues. When you are asked to find 3 by 3 matrix, the eigenvalues is a long one. To find the corresponding eigenvalues and its eigenvectors will give students hard time. So Chibuzor Mathematics quickest solver is dedicated to bringing quickest and fastest way possible to help students evaluate all these difficult abstract mathematics. I'm going to show you how you can find your eigenvalues and its corresponding eigenvectors with simple flip using a graphical calculator called TI-84 graphical calculator. This calculator is very advanced. TI-84 plus silver edition. It helps you to find eigenvalues and its corresponding eigenvectors. You can as well use this calculator to sketch your graph. This calculator can as well store data. That's why in most institutions, this calculator won't be allowed in the examination hall. Of course, this calculator has contained a lot of things if you know how to use it. So I will show you how you can manipulate the functions and make it to be on your own advantage using this TI-84 plus silver edition scientific calculator. And you can as well use the Casio. We have the Casio 991 Casio 991 ES Plus second edition. You can use this calculator to compute your eigenvalues and the corresponding eigenvectors. But how do you do that? Because to work with eigenvalues, you need to first start with the equation which is A minus lambda I. Of course, A is just showing us a square matrix. Lambda will be multiplied with some identity matrix in order for us to get the eigenvalues, and after which we use our eigenvalues to find its corresponding eigenvectors. So let's take the first question and see what we are supposed to do. In this first question, we've got 401, negative 210, negative 201. This is 3 by 3 matrix. So using the equation of computing eigenvalues of and its corresponding eigenvectors, we know that A minus this is A minus lambda I will be equal to 0. In case you don't know how we get this, you can refer to my previous video where we do 2 by 2, that is 2-dimensional 2 by 2 matrices and computing its eigenvalues and corresponding eigenvectors. So this means that we are going to this is simply going to be equal to this. So we say that this is matrix A minus lambda I. So this could be that 4 minus lambda, because if you open up, you can have your lambda outside, and if you have your lambda outside, for instance, let me take this. You have your lambda, and then we have a matrix. Matrix is 4. this is identity matrix. Let's have our identity matrix. Identity matrix, in this case, identity matrix in this case will be 1 0 0 0 1 0 0 0 1. This is an identity matrix. So we simply have this. So when we multiply this, we will get this will give us 4 minus lambda 0 1. We have negative 2 1 0 negative. This is 1 minus lambda here, 1 minus lambda, and this is negative 2 0, then 1 minus lambda. So now we are going to find the determinant of this, and you believe with me that to find the determinant of this thing here is going to take you a very long time. Of course, you have no choice. If you are in examination and you are given this, you must go through it, because you have to compute. First of all, you change this. You can start by 4 minus lambda into, you take 1 minus lambda 0 0 1 minus lambda, so that you have 2 by 2 matrix, and then you are able to get the determinant, and this will be minus 0. It means that whatever we are going to have there is going to be 0, so we simply leave that, and the next one will be plus 1 into we have 4. If you close this and this, we have simply negative 2. We have negative 2, then 1 minus lambda, we have negative 2 0. And you know how to find the determinant of a 2 by 2 matrix. So to do that, you simply multiply the corresponding columns. You simply take this 1 minus lambda multiplied by 1 minus lambda. So we have to open up this bracket, after which we multiply by 4 minus lambda. We do the same here. So it's a very long thing. So I want to show you how you can easily manipulate this using your calculator. So let's clean up this. So the first thing we are going to do, since we know that this is a 3 by 3 matrix and it is polynomial of degree 3, so let us expand this. So we will have lambda minus a, lambda minus b, then we have lambda minus c, because we have 1 2 3, we have 3. So lambda minus a, lambda minus b, lambda minus c. So let's expand this. This will be equals to lambda cubed minus a plus b plus c lambda squared, plus we have ab plus bc plus ca, and this will be multiplied by lambda minus abc. So with this, it will help us to find the solution for the corresponding to find the eigenvalues, which we are going to use to find the corresponding eigenvectors. So let's get some space here. So in this matrix, let's start with the first one. We have a plus b plus c. So a plus b plus c will simply be 4 plus 1 plus 1. And we know that 4 plus 1 plus 1 will give us 6. The next one will be to find what is ab plus bc plus ca. So ab plus bc plus ca is nothing but the adjoint. So ab plus bc plus be A, and to get the adjoint we must find the determinant. And what is the determinant? The determinant is simply A plus A, B, C. What we have here, A, B, C. This refers to the determinant. You have to pay attention to this so that you will not make mistakes. And the determinant for this matrix, you can put this in your calculator. You will get the determinant of this matrix to be 6. If you want to confirm how to do that, simply go to your calculator. Let's take the calculator. Here. Put it on. Go to the mode. You see number 6 is for matrix. Mat A. Then 3 by 3 is 1. So now you can put the values. So the values of these matrices are here. We have 4, 0, 1, negative 2, 1, 0, negative 2, 0, 1. So now to find the adjoint of this matrix, press AC, go back to matrix, shift option number 4. We are looking for mat, which is 3. It is simply the inverse. So inverse, and we are looking for the adjoint of matrix. So multiply by, what is the determinant of this matrix? It is 6. Multiply by 6. This will give you the adjoint. So the adjoint of this matrix is the diagonal. That's why we have 1, 6, and 4. So 4 plus 6 is 10, plus 1 is 11. So 11 is the adjoint for this matrix. So it means that we are going to have 1 plus 6 plus 4, which is 11. This is 11. Of course, this is our adjoint, and this is the determinant of this matrix. Therefore, now to conclude, to find the eigenvalues for this matrix, it will simply be, let's get rid of some of these things here. It will simply be A, that we have minus lambda I. This will be equal to lambda cubed, because remember we have lambda cubed here when we are opening up, minus 6. 6 is the adjoint, minus 6, but we have lambda squared, so it is lambda squared. Then we have plus 11, which is the adjoint, 11 lambda, then minus 6, which is the determinant, and this is equal to 0. Is that not interesting on how you manipulate something that could have taken centuries for us to compute and find these values? So plug this in your calculator to find the value for lambda 1 and lambda 2 using your equation mode. You will find out that lambda 1 will be equals to 3, lambda 2 will be equals to 2, and lambda 3 will simply be, the calculator will give you these two values. So what you need to do is to find the remaining value. The remaining value will simply be 1, because we are looking at 3 times 2 is going to give us 6. What other value will you add with 6 to remain 6? It is simply 1. So 3, 2, 1 is the eigenvalues that we need to use to find the corresponding eigenvectors. In the next video, I will take you through on how we can use these values to find the eigenvectors, because what we need to do here is, where there is lambda, we replace 3. When we are dealing with lambda 1 as equals to 3. In lambda 2 as equals to 2, we simply replace 2 with lambda. Where we see lambda, we replace 2. The same goes for lambda 3. Hope you have enjoyed the video. Click on the subscribe button so that you'll be notified as we upload subsequent videos. Remain your friend, Galagash.